Welcome to today's session. So I am Mrs.S.VIDHYA from SA Engineering College from the Department of CSBS. So today I am here to take you to the topic algorithm design technique and the greedy algorithm. So today we are going to see what is algorithm design technique. So what is an algorithm? So algorithm is basically a set of procedure, okay, so to solve a particular problem or finite number of steps for a finite sized problem. So the main aim of designing an algorithm is to provide a solution for a problem. So we have a problem and we need to find out a solution for the problem. So we need to describe the problem in a series of steps. So we define it in an algorithm. So the algorithm can be classified in various ways. So there are different types of algorithms and all these algorithms will fall in these four categories. So first is implementation method, design method, design approaches and other classifications. So our greedy technique will be falling in the design method. So today we will see what is greedy algorithm. So the greedy algorithm is very simple and straightforward approach to solve any kind of problem. So the decision is taken based on the current available information without worrying about the effect of the current decision in the future. So whatever decision we are going to take right now for a problem, it should not be affecting the future. We are not going to consider about the future and we are going to take the solution for the right now. So the greedy algorithm build a solution part by part, choosing the next part in such a way that it gives an immediate benefit. This approach never reconsiders the choices taken previously. So whatever solution we are going to take for the current situation and we are not going to consider the past or we are not going to consider the future. So it focuses on taking the immediate obvious solution that looks like it works the best right thing now. So if you are, for example, if you are hungry and you are going for a supermarket, you have only few amount in your hand. So what will you do? You will have to pick the most out of the money. So you need to pick up most of the items which you need to satisfy your hunger and with the amount which you have in your hand. So first you can pick up many items, as many as possible within that amount. You can bring it to the bill counter, you can bill it, and if you have any extra amount remaining, you can buy it for the remaining amount. So that is a real-time example given here for this greedy algorithm. So imagine you are hungry and want to eat something. You walk into a store with different food options. So this option would be look like all the food, pick the one that gives you the most of your coins. So you are going to pick one food which using which you are going to utilize most of your coins. So this is a simple example for a greedy algorithm. So you are going to traverse through this graph. So here there are nodes. You have to visit all the nodes and it should be like you have to use the minimum cost for the traversing the nodes. So if I am starting with point A, I should see which route is the easiest one and which is the smallest path through which I can traverse. So from A to B it is 4 and from A to C it is 5. So I have to traverse from A to B. So now I will traverse from A to B. So this is an undirected graph, so you can traverse through any direction. So from next point I have to traverse to another node. So I have to see from B to D if I go it is going to take 9 and from A to C if I go it will take me 5. So 5 is the smallest path. So I am going to travel to C. So from A to C I have traveled. Now I have to traverse to the next node. So from C to E it is going to cost me 3 and from B to D it is 9. So when I compare these both, C to E is the smallest path. So I am going to traverse to the smallest one. Next from E I have to traverse to F or D. So when I compare I can see E to F is the smallest path and E to D is 13. So it is going to be the highest one. So I am not going to take E to D. I am going to traverse E to F. So from now the last node which we have to traverse is D. So when we see from F to to D it is 2, E to D it is 13, B to D it is 9. So the minimum cost is 2. So from F to D we are going to travel. So this is the greedy algorithm. You are going to select the least cost part and you have to traverse all the nodes. You have to visit all the nodes so that none of the nodes are left over. So one of the greedy algorithm is fractional knapsack problem. So this is one approach where you are going to use the weight and the total value. So here you are going to have weight of the product and the corresponding values. So you have weight and the values given for you, and the total value and the total weight will also be given. So here we are going to solve the knapsack problem using this weight and values. So here is an example. So we have n is equal to 3. So the total number of items is 3 and the total weight is 50. So now we have the values given. So there are three values, 100, 60 and 120. So now the weight for these values are 20, 10 and 30. So it is for 100 value the weight is 20. For 60 value the weight is 10 and for 120 value the weight is 30. So this is the value and weight given, and we have n is equal to 3. So now if you see the value for the first item is 100 by 20, so it is 5, and 60 by 10 it is 6, 120 by 30, so this is the value by weight ratio. So using this we are going to solve the knapsack problem. So now we are going to arrange them in an order. So item number 1, 2, 3 and the value we are going to arrange it according to your weight. So the lowest weight is 10 and the corresponding value is 60. The lowest and the next weight is 20 and the corresponding value is 100. The next is 30 weight and the corresponding value is 120. So now we are going to solve this. So initial capacity of the bag is 50. So my bag can take only 50 weight and the value is 0. That is initially I don't have anything in my bag. I'm going to place now. So we have so many items. We have 3 items here. So we are going to place these 3 items in our bag. So we have to see the initial capacity of the bag 50. Now let us take item 1 according to the sorted order. So when we take item 1, the weight is 10 and we can pick it up because we have the total capacity of a bag is 50 and 10 is lesser than 50. So I can pick that item and I can place it in the bag. So I'm going to take that item and I'm going to reduce it here. So now my current weight of my bag is 40 and the current value is 60. That is the value I have taken item of 10 weight and the corresponding value is 60. So now I am going to take the item 2, the weight is 20. So it is lesser than 40. So I am reducing it, 40 minus 20. So this is my remaining value. So for 20 is my remaining value. Now the current value is 60 plus 100. So already my current value was 60 and now I am adding the 100 value to this. So my total value will be 160 now. So next is item 3. So item 3 weight is 30 but we have only 20 remaining. Okay, so the current knapsack problem capacity is 20. So we can take only 20 of its of the item 3rd. So now the final value how to calculate is we already have 160 and now the item 3rd 120 by 3. We have this and into 20. So this will give you the total value. So this is our total value. So now only 1/3 of the item 3 we have taken. We cannot take the entire item 3 because we don't have the weight. We have only weight of 20. So we are taking only 20% of the item 3 into our bag. So this is the knapsack problem. So we have to pick the items according to our capacity. So the next is Prim's algorithm. So Prim's algorithm starts with single node. Here we are going to traverse to all the nodes, and we are going to start with one single node, an arbitrary node, and we are going to traverse through the other nodes. Make sure that you are traveling to the node which is having the lowest cost. So this is used to travel to various locations, which you can check the distance between the locations. Whichever distance is near to you, you can travel. So this algorithm will help in checking the nearest path. So the working step is here. First, start with any arbitrary vertex. So you are going to start with any node and add it to the minimal spanning tree. So you are going to add the node to the minimal spanning tree. So one by one we will be adding to the MST. So at each step, add the smallest edge that connects a vertex. So now I am in a vertex A, so I have to travel to another vertex. So I will have to check whether it is smallest. So I have to take the smallest node and I have to add it to the MST. And last is repeat until all the vertices are included in the MST. So I have to make sure that all the vertices I have traveled and I have added in the minimal spanning tree. So this is an example. Okay, here we have nodes up to 8. So starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And we have the distances given. So what we are going to do is we are going to travel from 0. So the first step, I am taking the 0 vertex. So I am taking the 0 vertex and now I have to check to which vertex I can travel. So when I check, 4 is the smallest one when compared to 8. So I will go to vertex 4. So from 0 to 1 I have traveled. So now I have to check if I want to travel to the next node, which is the lowest part. So here if you see, it is 8, this is 11 and this is 8. So I am going to select a path which is lowest. So I will take 0 to 7. Okay. So you can even travel from 1 to 2. That is also the same. So I am going to travel from 0 to 7. So the way it is 8. So now I have traveled to 0 to 7. Now from 7 I have to travel to the next point. I can travel to 1, I can travel to 7, or I can travel to 11. Okay. So when I check the nearest, so the smallest one, 1 is the smallest part. So I am going to travel to 1. So from 7 to 6 I am traveling. So you can see the colored path to which I am traveling. So I have traversed 4 nodes. Now the next node which I have to travel, I have to check which is the smallest one. So when you see, from 1 it is 8, from 7 if I want to go to 8 it is 7, and from 6 it is 2, and here it is 8. So now I will travel to the lowest part from 6 to 5. So which is A, which is 2. So now I have traveled to 5. Now next node I have to traverse. So when I see here, from 5 to 2 it is 4, 5 to 3 it is 14, 5 to 4 it is 10, 6 to 8 it is 2. The lowest cost is 5 to 2. So I am going to travel from 5 to 2. So the next node which we are going to travel is from 2 to 8. So 2 to 8 the value is only 2. So which is the smallest one. So I am traveling from 2 to 8. Now the next is from 5. From 5 I can go to 4 using 10, or from 3 I can go to 4 using 9. So when I check which is the smallest, so 9 is the smallest. So I am traveling to 9. So this is the minimal spanner, for the final structure of the minimum span. spanning tree. So from 0 we have traveled to 1, we have traveled to 7, from 7 to 6, 6 to 5, 5 to 2 we have traveled, 2 to 8 we have traveled, from 2 to 3 we have traveled, and from 3 to 4 we have traveled. So this is one of the minimum spanning tree. So another way also you can do is, you can use from 1 to 8, from 1 you can go to 2, and from 2 you can travel. So that is also one minimum spanning tree you will get. So this is one of the minimum spanning tree for this particular graph. So now we will see a gate question. So consider the undirected graph below. So we have an undirected graph from node A to node G. So A, B, C, D, E, F and G we have. So these are the nodes we have, and we have the weight for the path. Okay, so now what we are going to find is, using Prim's algorithm, construct a minimum spanning tree starting with node A. That is, we are going to start with the node A, and you have to travel to all other nodes. So which one of the following sequence of the edges represents a possible order in which the edges would be added to construct the minimum spanning tree? So you have 4 options given here. So out of which you have to find out the minimum spanning tree. So we are going to start with node A. So let us start. So starting from node A. So from node A you are going to travel to the next node. So when you are going to travel to the next node, you have to check which node is the nearest one, the smallest one. So I am going to see here it is 10, this is 22 and this is 7. So when we compare these three values, the value 7 is the lowest. So I am going to travel to D. So from A to D, it is the least path and I am going to travel. Now I am going to travel to the next node. So when I see from A to B it is 10, here A to C 22, D to F 22. Okay. So when I see here A to B is the smallest one. So it is only 10 when compared with the other values. So I am going to take this value. I am traveling to node B. Now when I am going to travel to the next node, so I can see B to E it is 49, B to C is 30, A to C is 22, D to F is 22 and D to C is 26. So when I see here the least value, I have A to C and D to F. So I will travel from D to F. The next node which I am going to travel is from F to C, which is the least number. So from F to C I have traveled. Now I have to travel E and G. So when I see from F to G, it is smallest. So I will travel from F to G. I have only 5. So I will travel from F to G. Now from G to E, it is only 2. So I am going to travel from G to E. So from A, I have traveled to B. From A, I have traveled to D. Then from D, I have traveled to F. From F, I have traveled to C. From F, I have traveled to G. And from G, I have traveled to E. So this is the path we have traveled. So here we have option D, which is the right answer. You can check with the other options also. So from E to G we cannot travel, because from the question itself it is given that the starting node is A. So the first option will not be true. So next option B, AD, AB and AC. If you are traveling from A to C and then again C to F, then again G to E. So where G to E, we did not travel G vertex at all. So that is also not a possible case. Next option, A comma B, A comma D, then D to F, F to G, G to E, and again F to C. Here you have to travel in a order. So here this is also not a feasible one. So this is the feasible solution. So the next question, for an undirected graph, weighted graph given below, which of the following sequences of the edges represents the correct execution of Prim's algorithm to construct the minimum spanning tree. So this is also another gate question where we are going to find the minimum spanning tree, the path we have to find out. So here they haven't given any node to start. So we are going to consider any one node and we are going to start. So here first option if I take A comma B. So from A if I am starting A comma B, it is 1. Then D comma F. D comma F we cannot travel because it is not in order and we haven't traveled to D yet. So option A is not the right option. C comma E. If I travel C comma E, C to E I am traveling, then again C to F I am traveling, from F to D I am traveling, D to A to B, and G to H. So here it is given G to H, but G or H, neither of the option we haven't traveled. Both the vertexes are not at traversed, so that is also not an option. Okay, so next option C. So I am going to travel from D to F. It is only 2. Okay, then F to C 3, then D to A 5, then A to B 1, then C to E I am traveling, from F to H I can travel, and from G to H, and there is H to G, and G to I. So this way if you travel, you can travel all the points and none of the point is like we haven't traversed. Every point we have traveled. So this is the option. Let us see option D1. So if we take H node and we are traveling from H to G and G to I. Then H to F, F to C it is traveling, then F to D it is traveling, D to A to B, and C to E. So here this is not in an order. So we cannot travel to this. If you see this particular option C, D to F it is 2, D to F it is 2, F to C it is 3, D to A is 5, A to B is 1, C to E 7, F to H 8, then H to G 7, and G to I 3. So these are the weight for the graph which we have traversed. So option C is the right option. So this is all about the greedy algorithm. So today we have seen knapsack problem and Prim's algorithm. So next we will continue in the next video. Thank you.